Good morning. Ooh, it's hot in here. How's it going? Where's my surface? Thanks for coming. This was more complex than what I thought. All right, my name is Giorgio Sardo. Apart from dressing myself up for conferences, like I never presented during the Halloween day, so I thought, let's do something special for the attendees today. I work in the Windows Evangelist team, and I kind of write also code, although it doesn't look like I'm one of those. And with my team, we built a lot of applications, a lot of Windows 8 applications over the last years. And we've done a lot of experience, and I love in particular HTML5. And so today, in this session, we're going to talk about HTML5 games. And I set up a challenge, actually two challenges. The first is that I'm going to write an HTML5 game for Windows 8 from scratch. So you will see everything, like from the open project to the game running. The second challenge is that I'm going to do it dress up as a Yeti. And you might think it's easy, but did you see my feet? Like, seriously. So hopefully I will not fall down. Before we start with the presentation, let me show you just a few games that are in the store today that actually have been built using HTML5. And so this is my desktop. This is what I do at work. I just play, and that's why I love my job, right? I know I actually also have like Serious Up. But the first one I want to show you is something we saw yesterday in the keynote. We are very excited about this project that the Disney team has been working on in the last month. This is called Agent P Strikes Back. And everything that you see here is built using HTML5. It's touch-friendly. It works with my keyboard. It works with my screen. It works with an Xbox controller. And I'm just Agent P, and I can bounce, and I can go around. And look at the performance here. This is just amazing. Like, it's a steady 60 frames per second. And even if when you play on the Surface RT, like the game still plays very well. And it's actually very fun. Another game I'm going to show you is from a famous developer called Grant Skinner. They built this game a few years ago, and then they kept building on top of it and adding more levels. This is called Pirates Love Daisies. It's another application in the store, completely built using HTML5. Notice also the use of advertisement, like it's their way to monetize the game. So I'm basically the captain of a churn, and I need to get ready to fight rats and other animals coming in. And all of the gameplay that you see here is absolutely HTML5. Audio, graphics, everything is just built in HTML5. And it also supports nicely, it also scales back nicely to different resolution. It supports like the snap view, etc., etc. If you're very good at playing game, you can even play two games at the same time. How cool is that? So one hand on the right and one on the left, and you just play there. And another one that I'm actually had a lot of fun working on was Cut the Rope. And this was probably one of our very first games. We started with this as a challenge for us and for the Zeptolab team that built the game. Like, can we take an iOS application and build that application into HTML5? And so then that's when we take the challenge, and it took us some time. But eventually, the game that is a native app in Objective-C on other platforms is completely HTML5 built in Windows 8. And it was a great experience building it, and we got to a great performance. Like, you can see these ropes. Those are 20,000 triangles being animated on the screen. It's touch-friendly, like you get rich music. It's just fun. It's just an immersive experience. And so these are just few examples of the games that we're going to look at today. And there is one more that I want to show you. And actually, this is also the reason why I'm dressed up like this. Not just because I'm completely go nuts, but because the game that we're going to build today is about my family. It's about a Yeti. And so this is the game experience that we're going to look. So I'm there. I'm the Yeti. And I have zombies coming down, and then I need to hit them with the balls, and then I win. All right? So this is the game that we're going to build. And we're going to do it step by step, so we'll really show you all of the steps involved. Before we get into the code, let me share just a few words about the architecture and how we're going to build this game. Of course, you saw this slide before. This is the Windows 8 platform. And as you see on the left, you have the Windows Store apps. It can be built using C++, can be built using XAML and C# or HTML and JavaScript. And the area that we're going to focus on today is really the HTML, CSS, and JavaScript component. This doesn't mean that you have to build games in HTML5. Actually, there are a lot of excellent games built in C++. You saw some Unity games. You saw like 3D experiences. You saw Xbox Live titles. But HTML5 is great for casual game. So if you're not really building something extremely complex or extremely challenging, but still fun and still very popular, as the example I showed you, HTML5 is a great option. And you can do that using two components. One is the component of the browser, right, the IE10, and that is what brings you the hardware acceleration, that what brings you the new JavaScript engine and all of the new functionalities. And then you have the WinRT, which brings you all of the Windows APIs that you can use to connect to the device. Now, without getting into the details, this is IE10. A lot of new HTML5 features, a lot of CSS3 features. And we will touch on many of those today. And this is a quick overview of some of the APIs that are part of the Windows runtime and that we will also use today. From the ground, like the fundamental APIs, into the media stack with audio and video and more rich sounds, into devices, so like accelerometer, GPS, or different type of sensors, or data. How do you handle with web services? How do you handle secure communication? And lastly, the graphic layer. How do you build like a performant graphic in a game? And so that was my last slide. And now I'm going to slowly walk into my laptop. I'm going to just make myself more comfortable. Do you want me to code with the big hands? I can use those. But I thought it would be faster to just go ahead like this. And so I'm going to start and open Visual Studio. And obviously, you're all familiar with Visual Studio. This is the last version, 2012. And I'm going to open and create a new web project. Now, you're probably wondering, wasn't this session about Windows 8? Like, why are you opening a web project? Well, I want to show you that what we do is really HTML5 based, and so just work in the browser. And then at the end, we will complement it, and we will add even more on top of it, and bring it into Windows 8 app. So just stay with me and follow me on this. And the very first step is that we need to create a page. So we'll create a basic HTML page. Can you see the fonts? Probably. Let me make it slightly bigger. Let's go to 16. How about this? Excellent. And so we're going to create just a base here. And this is going to be, oops, I didn't add the script tag. This is our base. And I will explain this code. In this session, I'm not going to get into the details of JavaScript. I will focus on what makes special, like what is special about games and what some of the best practices. You immediately see this function, right? This is like an anonymous function, and it's basically a way to encapsulate your code into a sandbox. And that makes that sandbox secure. It's like a module that cannot be broke by other code that is into the project. So it's a good way to modularize your projects. And you probably see as part of the templates in Visual Studio as well. Use strict is a way to tell, like to use to like ECMAScript 5 engine, really make sure that my JavaScript is compliant and is nicely written. And then I'm attaching to the Windows add eventer, I'm creating an event for the DOM content loaded. And that DOM content loaded will call you when the application, when the browser, when the engine has the DOM loaded. In the past, you probably used the loaded event. And the difference is that the load event on a page calls you back once you have all of the assets, all of the images, all of the sounds, all of the resources ready. DOM content loaded calls earlier. It calls when the DOM is ready. And this allows you to be faster in your application. Then we're also going to create a canvas object. And we're going to talk about the canvas in a second. I'm going to call this canvas. I'm going to set the width to 136, 768. And then I'm going to reference my canvas from my init function. So canvas and context, canvas equal document get element ID, canvas. And context is canvas dot get context. Oops. And then the 2D context of the canvas. How many of you are familiar with what the canvas is? How many of you are not? Okay, so most of you are, so I will explain it very quickly. It's a drawing surface. It's a control where you can just draw stuff. It's easy as that. And you have only primitives to draw, delete, move, like if you're familiar, it's like an old language with the turtle on the screen. Not sure if you remember, Logo, I learned in the school, where we had the turtle going up and down, and drawing the line, then up. That's the canvas. But that's very powerful, right? And so I have the canvas here, and this is the very first step. Why are we using a canvas? Like, do we need to build all of the games, HTML5 games, with a canvas? Actually, no. You can use DOM, you can use CSS, you can use SVG, and we have games that are using those technologies. But the canvas normally is the best control for graphics and for animations, and it's also the one that is going to give you a better performance. And so the next step is really to draw on screen. Now that I have the canvas ready, let's also plug into the project some asset. And so I'm just going to drop a folder. And this folder has a number of images and that we will use during this project. And so from my init function, I'm going to call my function draw. So let's create this function draw. And what draw does is take an image and draw the image on the screen. And so new image, image.source equal assets dot, let's take, for example, sky PNG. And then context, which is the context of the canvas, draw image, 0, 0. This is the coordinate in the XY axis. And I'm going to launch this in the browser. Oops, it didn't work. Why? Is there some error? Exactly. The image is not there. And the reason is that, you see, I'm setting the source, and then I'm trying to draw on the canvas. But the browser, the engine, takes some time to load the image into memory and then draw it back to the canvas buffer. And so what you need to do here is add an event when the image is loaded. So load. I'm going to have my anonymous function here. And then once the image is loaded, we draw it. Okay? Let's try it. It works. I'm very hot. The temperature here is 100 degrees. And so it works, but notice what happened. You see the scroll bars here is actually larger than the screen. And the reason is because I set the full screen size, and this is not a full screen application. And so there are different techniques to adjust the layout, adjust the content of your site or your application to the screen. And one that we are very proud of, that we just introduced and we are also bringing to the standard community, is called viewport. But it's not the same viewport that you saw in the past. This is actually a new CSS property, and it's super powerful. So I just create a style here, a style tag. Okay. And I add this viewport property. And take a look. This is my new CSS property. It's becoming a standard. And the viewport basically says, I'm a developer. I know exactly what resolution and what screen size I want to target with my game. And that is my resolution with an 8. And so you, browser, or you, engine, please take my content and rescale it to keep the proportion of this size. And so when I run the same page again, what you're going to see is that as I scale the browser, the content readjusts automatically. Isn't this awesome? Doesn't matter, and this is valid for any HTML control, right? It's not just the canvas, like anything that you have on the page. Now, of course, there are use cases for this, so we are still encouraging you to use responsive design patterns. But for some scenario, having a viewport that rescale the content is actually a very good thing for developers. Also, when you build the games, you will probably, for Windows 8, you will need to think about different screen sizes. Like some screen might be slow, some screen might be a high resolution screen. So you want to find the right trade-off. This is the shortcut, right? You target one size and then you just ask to scale. Obviously, if your assets are designed for a very small screen and you ask the browser to scale them up to a screen like this, well, the resolution is going to be pixelated. They're not going to look awesome. And so eventually your strategy could be to have two packages of assets, one high res and one low res, and then adjust and do the best compromise starting from the assets that you have. OK, now I have one image. But of course, like my game will need many images. And so how do I load many images? I have two options. One is I just take this code, and I do copy and paste, copy and paste, copy and paste, copy and paste, copy and paste. And I do this, right? And I don't like this option. It's not modular. And so we're going to build here. I'm going to call this preload assets. And I'm going to build a little function to preload all of the assets. And the idea is that when you start the game, you preload all of the images that you will need during the game. And then once you are done preloading, that's when you start the game execution. And so look at what I'm going to do a few tricks here. So I'm going to create a function. And I'm going to call this add image. And inside that function, I'm going to encapsulate basically the code that I had here. Okay? Then I don't need this. So I'll just park it there for now. And I will put as the URL of my image source. And also, I don't need this. So I'll park it here for now. Now, I need a way to count how many resources I'm preloading and how many are done. So very simply, I'm going to do I'm going to have a function here called toAdd to preload. I'm going to set it to 0. Then inside my add image, every time I add an image, I'm going to say, hey, I have a new asset to preload. And once the asset is preloaded, I'm going to decrement that counter. Make sense? So I add, and when I'm ready, I remove. And now I need a way to check when I'm done, right? And so I'm going to create another function, and I'm going to say check resources. And this check resource is going to check if the to preload is equal to 0. And if it is, then I'm ready to draw. If it's not, then I just set a timeout, on myself, on check resources. And I will wait 2 milliseconds. And so I will keep looping on myself, waiting for all the assets to be loaded. Once I have these two functions, I need to do two things. One is add images. And so now I will call my add image. And I'm going to pass the argument of the sky. And the other one, so let's create a draw function here. Let's put this here. And the other one is called check resources. I'm missing one more thing. Once I load the image, I also need a way to store these images. And so I'm basically going to return the object image. I'm going to save that object into, for example, the variable sky. And actually, you know what? I'm going to make this variable global. Sky. Okay? And then once I'm done, I call draw. And draw is just going to call the context function is going to draw the sky. Let's build a function for that. Draw sky. Draw sky. That's it. Now, if we run this, if I wrote all the code correctly, did I wrote correctly? Any error or typo that you saw? You cannot say later once it fails. So this is your time. Okay? So let's run it. And I should see exactly the same. Yes. Wow. Good. And now this makes very easy to add more images, right? So for example, I can have mountain. And I just add a line here. I add a variable on top for my mountain. I copy this and I say draw mountain. Draw mountain. You see like why I did this? Because now it's very modular. It makes this very easy. And so what we should see now is two images overlay on top of each other. My sky and my mountain on top. And the canvas, you know, is like a buffer, right? So as you write or draw on top of it, it remembers what you wrote before, and it just keeping on adding on top of the previous layer. And so now we added, now we have we preloaded all of the assets. Actually, let me add a few assets that we will need during this game. And so I have here a few more variables. And so these are different images that we will use in the course of this presentation. And then new images. I can remove this. And then I'm done. I can even collapse this because we will not need it anymore. Everything clear so far? Any question? I'll take it later. I'll get back to the question later. I have one slide at the end. And so now I have a beautiful mountain and a beautiful sky. but we're missing the game action, right? How do you do the game? How do you do the animation? How do you do the agent P doing this or stuck in with the, I don't know, the toilet thing on the wall? And so to show you that concept, let me show you a video that hopefully explains you how animations work in HTML5. Oops. How do I play this video? Ladies and gentlemen, let me just quit this. And you never saw this happen in real time, did you? Start automatically. So you should start. Here it is. This is how animations work in HTML5. It's like a flip book. It's like you create a lot of assets, and then you animate them very quickly. And if you have one asset that is like this, and then you have the other assets like this, and then the other one that is like this, then another one like this, and then you animate those in a loops, you're going to see an animation, right? It's a basic technique. It's called sprite. And that's how, that's how all of the animations work in HTML5. And that's exactly what we're going to do here with my game. And so the animation that I want to create is about zombies. So I create here, you remember the zombies walking on the screen? We're going to animate those zombies. Zombies. And so I'm going to add a new function. I'm going to call it draw zombies. And this function is going to take an array of zombies, and then it's going to draw it. But let's start with just one of them. And so let me take a variable here. We take the zombie1 sprite. Zombie1 sprite, I'll show you how it looks like. It's one of the images here. You see? This is a sprite. It's an image with different stages. And if you look at the bottom, you can see that the legs are slightly off. There is an offset in the legs, which means that once you start replaying those very quickly in a sequence, in a loop, it will give you the impression that it's walking. And so all we need to do is to draw this on screen. So let's go step by step, right? So first step is draw image. I'm going to say sprite. And I'm going to draw it randomly for now on the screen. So random, put it in a random position here and a random position there. Okay? And then let's also focus just on the zombie for a second. So I'm going to comment the sky and the mountain. Do you know what is going to happen? What do you expect will happen when I start this page? Here it is. Nothing, right? I'm drawing once, but there is no timer. There is nothing that does the animation. And so I basically need to create a drawing loop, something that goes recursively and keep drawing. How do you do loops in JavaScript? What functions do you use normally? Come on. Ayet is writing code, and you don't know how to write timers in JavaScript? You know. Set timeout, set interval. Those are like the old way to do callbacks. The challenge with those is that they're really trying to approximate the clock of the machine, but they're not aligned to the GPU. They're not aligned to the drawing cycle of the GPU. And each of your machine has a graphic card that has a drawing cycle. And so what we built in IE10 is a way to tell to the developer when the GPU is ready to draw on the screen, we call you back, and that's when you execute your code. And that allows you to go faster. That allows you to save battery, because you're not just calling code randomly and then hoping that somewhere the GPU will draw it. You're giving the content to the GPU only when it's ready to draw. And that function is called request animation frame. And so inside my draw, I'm going to make this draw a recursive function. And I'm just going to call myself every time the GPU is ready. And I'm also going to keep track of which frame I'm at. So I'm going to have a counter here, frame, let's say, plus equal 1.1, for example. Okay, now I have a drawing function that keeps looping on itself. And so when I execute the same code, look what happened. You see? Now I'm drawing myself. And you remember what I told you. The canvas is a buffer, right? And so it just keeps adding on top of the previous layer. And that's why you see all of these animations. If I re-enable the sky and the mountain, you will not see this effect. Why? Because basically that sky and mountain is a full screen image that is covering the background. If you don't have that, you can just call a context.clear rect. And this is going to clear the canvas, so that is going to reset the canvas from scratch. But for the purpose of this, like we already have images that are covering the previous layer, so this is good enough. I don't need to add any more content. But still, if we look at this, there is a challenge. Well, apart from the fact that it's just jumping around, I see the full sprite, so I see 3 images, and I'm not seeing a smooth animation. And so how do we go and proceed with that? Let me show you a slide that explain you some of the let's go here. PowerPoint is not sympathetic today. Okay, this is one of the overload of the draw image function. You saw the basic method is just draw image coordinates x, y. This is one of the most complex methods on the canvas that gives you more flexibility. And so you start from a source image, is the one in yellow, and you say, crop this image, starting from this sx and sy for this width and height, and then remap it on my new canvas, eventually make it larger, make it longer, change the position. And so we're going to use this. And you see the first argument is an image. The other 4 arguments are the rectangle of the source, and the next 4 arguments are the rectangle of the destination. And so let's do this in code. And this is where I will need some help. All right. So we go here. Let me split this in different lines so it's clear, it's easier to understand. And so for now, I'm going to say 0. I'm just going to drop it on the 0 coordinate. I'm going to take the sprite width. This is the dimension of the sprite. And I'm going to divide it by 3, so I get just 1 image. And then I'm going to take the sprite height. And this is my source. And the destination will be, again, 0 for now. And then I will say the same, sprite width divided by 3, and sprite height. Oops, that's it. And so when I run this again, I see only 1 element. Okay? Now, how do I move this element across my images? How do I go 1, 2, 3, 1, 2, 3, 1, 2, 3? I basically need to change this coordinate. And so what I will do is a little trick. We'll do floor of my frame divided by 3 multiplied for the size of 1 of each of the sprites. And so what you will see now is my animation. You see? Eh? What do you think? And so a lot of developers, myself actually, when I first approached HTML5 games, I was scared, like, no, I'm not a designer, I don't know how to do animations. Then I found this trick, and I'm like, that's easy. Like, is that it, really? Are you telling me that all of these games are using this technique? Yes. And so now that we have this animation of my zombie moving, I also wanted to move it on the x-axis. And to do that, so I'm going to add an array of zombies. Hurrah! And it's just an array, and then you see that I'm pushing into an array like different zombie with coordinate x, y, and then a direction to understand like which direction they're going, and a sprite because I have 2 different sprites. And so draw zombies. Now I'm going to loop through this array. So zombies.length, and then for each zombie, I'm going to take the sprite of that zombie. So zombies y.sprite. Okay. And then I'm going to draw the zombie. You saw that I'm basically seeding the initial position, x, y. And so I'm going to use that position here. So I'm going to do zombies y.x. That's my initial position. Zombies y.y. And that's my epsilon. Okay? So let's run this. Am I missing something? Oh, I'm not calling the zombie anywhere. So I need to call the zombies here in my init. And now I have my zombies animating, right? They're still not moving. Why? Because obviously within my drawing loop or in some other loop, I need to change and update the position of these zombies. And so I will do it here. For simplicity, I will do it in the same function. And so after I draw one image, I'm basically going to just change the position of the zombie. So I'm going to say zombies y.x, and I'm going to increment it of, for example, 5 plus equal 5 per the direction of the zombie. Direction. The direction is basically a 1 or -1, and it tells you which way the zombie is walking. And so when I run this, you should see zombies moving, like Michael Jackson. And of course, now they're bouncing outside of the screen. So I can add just a little logic here to say if my zombie coordinate is either too large or it's too small, then I just invert the direction, basically. And I ask them to bounce from one side, from one edge of the screen to the other, so -1. And so when I do this again, you should see them bouncing from the edges. Super simple, right? Of course, your game, hopefully, will be a bit more challenging than this. But this gives you the idea of the basic components, right? The basic elements that you can use. And I have different zombies. This was fun. Now, what's next? We have an animation going. How do we handle the input? How do we allow the user to play and interact with the game? And so to do that, I'm going to create a function. And I'm going to call this function setUpInput. And here's my requirement. Because it's a Windows 8 application, and because I want to create a great experience for my users, and I also want to pass the source certification, I want this game to be accessible with the keyboard and mouse or with the touchscreen. I want to do both input, right? So I don't know if the user will use a tablet or will use a PC, but I just want to please him and have him have a great experience. And so normally, if you try to do this in other platform, as a developer, when they ask you, your game needs to be touch and needs to touch friendly and mouse friendly, what do you think? Crap, I need to write two different things, or two different lines of code. And so the Microsoft and the Internet Explorer team have been working very hard to make this super simple for developers. Touch is a very important characteristic of the standards. And for years, for ages, we never had a proper way to do touch in HTML5 in a standard way. Apple proposed a model, but that one model obviously was proprietary and had some challenge. And there is another session from Jeff Bartoff here that is going to focus on why we made the decision with our new model. And so we created a new model. It's called Pointer. And we also made this available, and we submitted it as a W3C specification. So we didn't want it to be only a Microsoft thing. We want it to be a standard. And you can imagine that Microsoft has years of IP and research and development on touch, but we still thought that the right thing to do was to donate this as part of the open standard and open community. And so this is actually something that you will see in W3C. It's been extremely successful so far. And I'm going to show you here how it works. And so it starts from the document. And then I'm going to add an event listener. And instead of listening for mouse move or mouse down, I'm going to use the concept of the pointer. For example, pointer move. Function. And the pointer basically is a way to say, I don't know exactly, oops, I have, okay, let's write this again. Oh, document. You guys are not telling me anything. Document body. That's it. Nope. 128. Did I write something? Let's go back. This is one of your opportunities to show how bright developers you are. Still there. Anyone? 122. One 122. Head. Did somebody change the code when I was walking? Sorry, any idea? I'm going back until you tell me something. You realize this, right? But, okay, this is definitely not working. This is where the backups is helpful. You know why? Step by step. Let me see which step we are at. Step 4. Ta-tang. Ta-tang. You might think that I was going to run into this, right? Me too. See? All right. So we're back to our game. And now we're going to add input. It's one of the first things that you learn as a speaker. Like, I always have a backup. Thank you for your help, by the way. That was very helpful. I really appreciate it. All right, and I have my setup input function. Okay, let's go more quickly now. And I'm going to add my event listener, MS pointer, move, function, blah, blah. And I'm back here. All right. And then all I need to do is just check the coordinates. So I'm going to have an event here. And I'm going to set a variable. Let's call it, for example, pointer x equals 0. And I'm going to update this variable with the position of my pointer, right? And the idea here is that it doesn't matter if I'm touching with the key, with the mouse, or with my fingers. I'm still going to go through that pointer event. And so as a developer, you have one event for input, and that event will capture everything from keyboard to touch to pen, like even a pen. So it's very easy for you to code it. And you have a lot of properties to customize it. And the other one that I want to add is also that we will use in a second is pointer up. So when I release my key. And we're going to do something with this in a second. I also, like we have the mountains, we have the sky, we have the zombies. We are missing the Yeti. And so let's draw a Yeti. And for the sake of time, I'm just going to drop this snippet. This is my Yeti. And I'll explain you what it does. I'm drawing my face, so I have a face image, and I just coordinated in the right position. And then I'm taking the body of the Yeti. So this is the source. I'm taking the Yeti here, and this is the destination. And the destination core is using that pointer x variable that I just created, which means that as I move my finger around, the Yeti should follow basically my finger. So let's try this in action. Okay? You see, now I'm moving the mouse, no hands, just mouse. And now if I use the finger, oops, it doesn't work. Here's the thing. The browser by default is set up to enable this gesture. You see, like pinch and zoom. Like that's what IE is built in. That's like, for most of the sites, is very helpful, like the experience of just navigating with the fingers. Because this is a game, you want to say, no, actually, I want to handle this myself. And you can use another standard property called touch action to say, I know exactly what I'm doing, and so let me handle it. And now if I touch, I'm going to call my events, right? So the point there is my finger, and you can see that I lock the animation on the x-axis. Now this is fun and good. When I release the finger, or when I press and release the click, I need to drop this ball. So let's write that code also. Going back to my drawing loop, and I'm going to add a draw balls. And then I'm going to just use this code snippet. And the code snippet is going to go through the array of balls. So let's create this array, balls, new array. And it's going to draw an image at the coordinate of that array. Where do I create the ball? Well, exactly when I release the finger. So if we go back to the MS pointer up, that's when I add basically a new ball to my array. So balls push. And here it can say, for example, x, take the coordinates of the last pointer, x, and y, let's just set 0 for now as a start. And also notice here that during the array, I'm also updating the size, like the position of the ball. What I'm missing here eventually that we will do later is the detection, right? So right now I'm just drawing. So let's draw this again on screen. See as I release as I click, I see my animation of the balls. It's snowing balls, but I'm not able to kill the zombies. Everything good so far? Excellent. So now, how do we do the hit detection, right? And again, this is one of the areas where, depending on the complexity of your game, you might have more complex algorithm, you might have a physics engine, you might have a number of things. This game is relatively simple. And so I have my test collision function, which is, I'm just adding like something to the array prototype here, is a remove function, basically to remove from to. So this is just a little snippet of code. But this is the core, right? For each zombie, I'm looking through the array of zombies, and I'm checking, is the zombie very close to the ball? Like, are they within the 100 pixel of proximity? And if they are, then I remove the zombie, because that means that I have an hit. And I also return true. And so what I can do here is, if test collision, and then I pass the balls that I was drawing, E, then it means that I hit something, and that it's something we'll call the remove from my array of zombies. And so if we run this again, you should see that as I click, you see the zombie disappearing. It's working. Now this is very quiet, so let's add some sound, right? Thank you. Thank you. Thank you. So next step is sound. A lot of people think that the HTML5 audio is not capable of running games. I disagree with these people. Actually, for most of the game, it's great. As you get into more complex scenarios where you need to play 50 audio samples and synchronize them at exactly the same time frame, that's when you start seeing challenges. But for basic games like this is actually perfect. HTML5 audio is perfect. And so in my assets folder, I have an audio file, and it's called Impact, and I'm just going to drop this into Visual Studio. Now, something I learned yesterday, actually I didn't know, but you see here how the audio tag is ending. That is, for some reason, doesn't work in most browsers. So what you need to do is just close it the proper way, like the full way. That's it. And so I'm going to close this, I'm going to call this Impact. And then when I do the hit, I'm going to, this hit, I'm going to play the sound, play. So I start with this. And now as I hit, you hear? Oops, I'm too good at this game. But you notice something, that you heard the sound only once when I hit 3 zombies in a line. And that's really up to you to decide how you want that sound to behave. If you want to hear 3 different sounds, you can basically pause and then restart the sound. So you can pause it, you can say, let's reset the current time to 0, and then I play it again. And so now if I try to do the same, you heard? I have 3 sounds in a row, because basically I'm interrupting the same. Or you could have 2 sound elements and just play those simultaneously. Just be aware that when you go to eventually lower-end devices or some of the ARM devices, you cannot play like an unlimited number of audio files. Like you have a limit, and that limit depends on your machine. This is just like a technical limit. All right, so we have our games. And we built in 40 minutes a little game from scratch, from 0. But hey, this is still a browser, right? And so, I support this, which is nice, but I'm still playing inside the browser. And this session was about Windows 8. So let's create a project in Windows 8 now. So I'm going to create a new template, new project. I'm going to go into the Windows Store. I'm just going to select a blank template. And now I'm going to rewrite all of the code from scratch. So just give me a few seconds. No, I'm joking. Here's the part that I love about the new platform of Windows 8. The HTML5 engine that you used to know, that you are familiar with in HTML5 in the browser, is exactly the same that we use to run Windows 8 apps. Exactly the same. Not different performance, not different behaviors. It's exactly the same. Which means that I can go into my web project, and I'm just going to do this. Open File folder, and I'm going to copy my game file and my assets folder. And then I'm going to my new Windows Store project. And I'm going to copy everything. So I just passed my elements there. This is a blank template, right? Then I go inside Package App Manifest. And I just changed the start page to be game. And look what happens when I press start. Boom. It just works. I noticed on the touch screen is a ball showing up. I'll get the question later, sorry. My Yeti will be upset otherwise. And so, but so far we've done only HTML5 standard stuff, right? Let's add now some Windows 8 API. Let's really use the platform and the devices and like more capabilities to light up this application. And so, very first step, I'm going to go back actually here to my previous default page. Everybody loves application with a nice style. And right now, this is my tile. Let me drop it here. This is my tile. It's the Visual Studio default tile. And so let's go into images. And I have a number of assets here. I'm just going to copy those images inside my Windows 8 project. And then from the manifest, that's where basically you can decide all of the tile, like the small, the wide. So let's pick like a wide logo, the small logo, et cetera, et cetera. And so if I run this again, what you will see is my new splash screen. And then you see the default page, right? But in the back, now I have on my start screen, now I have my nice, beautiful looking tile. Easy as that. It's just an image. Then the next step is, of course, you're not going to throw the user inside the gameplay. You probably want to have a welcome screen. And so that's my default page. And for the sake of brevity, I'm just going to have a link here, basically, that goes to the game. So let's point this to my game. That's game HTML. Let's add it a class. And this class, let's call it just a random name, start game button. And then I also want to tweak a bit the CSS property of this page. And you can see that I already have a default CSS style sheet. So let's start from there. And let's drop a few lines of CSS code here. And let me explain you in a second what we're doing. First, I'm setting a nice background image. Probably, like you will see, this is where you build your application. But now I'm just going to use an image as a nice background, and that's it. Then I'm taking my start button. And everything is normal. I'm setting an image for that button. And then I have an animation. This animation is actually a CSS3 animation. David did a session yesterday where he talked about the new HTML5 functionality. This is one of them. And it makes very easy to animate HTML object, where basically you have an animation. You say, this is where I define it, and these are the keyframes of my animation. So I go from up, then I scale it down, then I scale it up again. So let's run this again. And this is the new page, right? You have a background. And this is my link. You see start game? That's the link where I'm applying the CSS3 animation. It was that easy to do this effect. I think about all of the JavaScript code that you wrote in the past. Now, CSS allows you to do this almost for free. And by the way, it's also hardware accelerated, right? So I think this is very nice. I love it as a developer. The challenge with this page is that as I start snapping it, like, of course, here it's still resizing. But then this is not a good experience. And so you also need, as you think about Windows Store application, you need to think like, how will they look on different screen sizes? How do they look in portrait versus landscape? How do they look in a snap view? And again, CSS3 make very easy to understand in which state you are at. And so, for example, you see here the media query. This is one of the CSS3 properties. And tell you exactly in which of the different stages you're at. And let's say, when I'm in snap mode, I want to show something else. Right? You might show the same game, or you might want to show something easier, right? Because you don't have a lot of pixel space. And in this case, I'm just going to basically change my background and then hide the button. And so when I run this again, and I snap it, for example, I'm showing the results. Now, this is just an image, but in reality, that's where you will need to build your good app, right? You might think that those are little details, but those are really what makes your game or your application different. Quality is very important. Like, we're investing a lot of time on quality. We don't really care about normal applications. We want great applications. And we want to help you to build great applications. And that's why we have a lot of content about quality development here at Build. Something else that I want to, like one of the features that I love about Windows 8 is the share contract that allows me to share easily the state of my game. And so let's plug that into my game. So I'm going to create here a new function, and I'm going to call it, I'm back into my game file, right? Init share. And then I'm going to use a little snippet. Oops, I don't need it. There it is. And this is going to take a Windows API, and you recognize it immediately. This is part of Windows RT because it's in the Windows namespace. It takes the data transfer model method, and then the manager for that. And you're basically attaching to the event data requested, which means every time the user swipe from the right and click share, call me back inside the application, and that's where you create a package with a few properties. Can be text, can be the URLs, can be images. You can have complex custom data. In this case, I'm just sharing some text. And so let's try this in action. I also need to initialize it in my init. Then I run it. So same game. I pull the chance bar, click share. Oops, sorry, I need to go here. You notice I didn't see it because I added to this page. Now we are on two different pages. Share. And now I have my list of applications that can share content. And so since we are live, Yeptis can write win games in HTML5 in an hour. And I'm going to tweet this on Twitter. So probably you're already seeing this right now on Twitter. Easy as that. And now you have a share functionality. Now, one suggestion here. You can see that my share package is static, right? I'm always sharing the same information. That's the basic. Probably what you want to think about is, what is the content that I want to share? And so as the user goes through the application, you might want to update this context. For example, you might say, hey, you just unlock a new level, or this is your new score, or create specific images. You could even take like a screenshot of the canvas and share that canvas as an image into your blog post. All of this is possible on the Windows 8 APIs. And the last thing I want to show you is, how do we use the hardware? You have a nice surface in your hands. How do we use, for example, the accelerometer? And so that, again, is super simple, accessible from JavaScript. I have an init accelerometer function, which is plugging into the Windows runtime. It's taking the default accelerometer sensor. If it's available, it starts reading the position, and then it just basically translates the accelerometer to my pointer coordinates that I had earlier. Notice also that if the accelerometer is available, I'm going to return true. And the reason is that when I go to set up input, I'm basically going to hide this if the accelerometer is not available. And then I also need to call accelerometer init here. Now, this laptop doesn't support the accelerometer. So I'm going to deploy this as a remote machine, or on a remote machine. And in case you didn't know yet, from Visual Studio, you can do remote debugging on any device, including Windows RT devices, including your Surface. And so when you go to debugging and you choose remote machine, here if you type machine name and locate, this is going to find the machine on your network. You just connect to your machine, and then you start running your app, for example, on this device, but debugging from Visual Studio. Now, for the sake of time, I already have the app here. Let's see if it's still there. Yeah. And so if I run my Yeti ball, let me see. Running the right one. As I move the device around, you can see that I'm moving my surface, and that's capturing the accelerometer movement, and it's translating that into position. And that was easy, right? Just a few lines of code. And you can imagine debugging this from Visual Studio, from your machine. What happened? Oh, it disappeared. And that was it. So in less than an hour, actually, we built a new game in HTML5, starting from scratch, then ported to Windows 8. We used the Windows runtime. I've done all of this dressed up as a Yeti. But hopefully this shows you how simple it is and how beautiful, how fun experience is to build games in HTML5. I'm actually excited about this. Now, we are packaging this source code into like a training course. We will probably share it somewhere on the web in the next 2 weeks. My team is working on this. If you want access to what I just used today, please send me a tweet. And so as soon as it's ready, then I'll make sure to send you back, to send you a reminder. I also want to call out a few things that might help you. Right? Today, I wrote all of the code from scratch. That's good to understand the basics. But the reality is that as you build more complex games, it's always good to have frameworks or to have libraries that can help you accelerating the preloading, can help you accelerating like different parts of your projects. And those are just some of the libraries that are available out there. Create.js is, for example, one of the most popular. It's built by Grant Skinner. It was used for the Pirates Love Daisies game that you saw earlier. And by the way, Opera moment. Grant Skinner is in the room, and so you can eventually go and talk with him later if you have any question. And I want to thank Grant also for all the contribution he's done to the community. Another popular library is Impact.js. It's another engine to build games very easily. The Thinking Pixel Lab, the Pixel Lab team built like a preloader. Like you asked me a question, how do we do this preloader? Do we need to write it ourselves? Well, I did it to explain you how it works, but the reality is that there are already preloader JavaScript libraries for audio, for images, for videos, and Robbie did an amazing job creating like a very little framework, a shim that you can plug into your project and use to preload the assets, and do it that dynamically, like with map files, XML files, so that's very rich experience. You can also prioritize different images or group them in assets. One of the things about preloading that I want to share is don't try to preload 5 million assets at the beginning of the game and then run the game. Load only the images that you need at a specific time. This is just a performance trick. You probably heard it before in the performance session. But you always want to have in memory only the assets that you need at that point. If you don't need something, just release it from the memory. Don't load it. If it's a video, remove it from the DOM. Right? That will help you accelerating the performance. And there are other frameworks like Box2D that you're familiar with, like the physics engine. I put here also jQuery because why not? Like it's a great framework for. Guys, you didn't tell me anything. There you go. I put here jQuery also because it can be helpful. For example, with Cut the Rope, like you see the initial experience of sliding on the boxes, that was built using jQuery. Okay, I'll give you just a second to take images. Or I put the costume later if you want. And then obviously on the MSDN you can find additional resources on games, and there are other sessions here at Build where you can find more user experience and best practices for Windows 8 games. With that, I want to thank you. Please send me a feedback if you like this session, and I'm here if you have any questions. Thank you very much.